Hello, welcome back. In this lesson, we're going to create some sound using the motion of a bunch of pendulums moving together based on some simple harmonic ratios. This work is very much derived and inspired by the Simple Harmonic Motion series by Memo Atkins, link in the description down below. We're going to take some of the ideas we've learned in the two previous lessons and combine them in order to get this project done. So let's get into it. So what I've done here is I've remixed our blank sketch and put in some of the basic scaffoldings for our audio sketches. We have a master volume we can adjust, and then we have a ready variable that gets triggered to true once we press the mouse, so that we have a space here where we can start any kind of audio processes if we need to. And then in Draw, we can prompt the user to actually click the browser in order for the audio to start. So we have that structure in place. So for this example, we're going to create a pendulum. And a pendulum is just going to be an object moving left to right, and we're going to use a sine wave as the oscillation of our pendulum. And there's many ways we could do this, but for today's example, we are going to use an LFO. Just because we've learned about LFOs in some of the previous lessons, we're going to put them to work here to help us create a pendulum. So if you'll recall, an LFO is a low frequency oscillator. So it's an object that will oscillate, but not quite at audio rates. It's going to go at some lower frequencies, which will be useful for application here. So we're going to create an LFO. And what we're going to do is we're going to use this LFO to set the movement of an object. So we're going to need some kind of a way of measuring the signal that the LFO is giving us. And then we're going to use that signal to set a position or something like this. So Tone.js has an object called a meter. Now, normally you would use a meter to, if you had a sample playing, you wanted to know the volume, you would use a meter. But what we're going to do is we're going to apply this meter to our LFO. And that's going to measure the overall amplitude of the signal, and that's going to reflect the movement of the LFO itself. So just like with the waveform object, these the meter and the waveform, these are kind of utility objects that allow us to monitor the signals we're working with. Let's make sure we start our LFO. And then in Draw below, we're going to write some code that's going to take the LFO and then move a circle back and forth. So just to see that it's working. So let's first let's grab the value from our meter. We're going to say this is going to be the amplitude of our LFO. So first let's grab the value from our meter. We're going to call this value position. Because we're thinking of a pendulum, this is going to represent the position for a pendulum left to right. So this position, we're going to say this dot get, we're going to say meter dot get value. Now, by default, what the meter returns here is a number in decibels. And what we're going to do is take our meter, and we're going to say meter dot normal range equals true. And that's going to mean that the values returned by the meter are going to be from 0 to 1 instead of a number in decibels, which is a little bit harder to work with. And then we're going to say take 0.5 and subtract that value from 0 to 1. Yeah? And that's going to give us a number between minus 0.5 and 0.5. So because we know that meter is between 0 and 1, right? If we subtract from 0.5, we're going to go from negative 0.5 to positive 0.5. And the reason why I'm doing this, I'll explain in a second. But first, let's draw something. So the x-coordinate of our circle, we're going to map the LFO's position, which goes from minus 0.5 to 0.5 now. We're going to map this to a number, let's say between 100 and then width minus 100. And then we're going to draw a little ellipse at this position. Let's center it, and let's make sure we have a fill color that we can see. Okay, so this is what that looks like. So we can imagine like we're looking sort of top down here on our low frequency oscillator. By default, it's using a sine wave, right, to oscillate. And it's oscillating at this rate here, 0.85 hertz. And yeah, it's moving, swinging back and forth. If we really wanted it to look like a pendulum, we're going to add, just for fun here, we're just going to add a little line from x height over 2 to width over 2 and 0. And we can't see the line because it's black. So let's set a white stroke. Okay. So that's our little virtual pendulum here. So for this example, obviously we want to turn this into some kind of music generating machine. So we're going to make it so that whenever the pendulum crosses the middle point, right, we're going to have it play a musical note. Right? So we're going to pretend maybe we're hitting, you know, some kind of invisible thing here, so that every time we cross the middle, we're going to play some kind of musical note. So in order to do this, this is going to be similar to the trigger we did when we had to visualize a waveform. Right? We want to be able to say, you know, are we coming towards from the right side here and then suddenly becoming on the left side? So in other words, is the value of position, right, positive and then all of a sudden becomes negative? That means we've crossed the 0 point. Or vice versa, is it negative and then all of a sudden becoming positive? It means we've crossed the 0 point but from the other direction. So in order to make that determination, we need to know where we are, that's position, and we also need to know where we were just one frame in the past. So the only way we can know this is we have to record it somewhere. So we're going to make a variable. We're going to call it prev pos for previous position. Okay, so I'm just shortening the name here so it's a little bit easier to type. And we're going to make a little determination. Okay, so we're going to see, all right, the coming from the left condition, right? If our pendulum is coming from the left, that's going to happen if the position, right, the current position is positive and the previous position is negative. On the other hand, if the previous position was negative, right, and sorry, the current position is negative and the previous position was positive, then we've just crossed coming from the right. So if either of these conditions are true, so if left or right, remember the two upper bars like this, two vertical bars mean or, and the two ampersand here mean, sorry, where is it? In logic mean and, just as a reminder. So if either of those things happen, we want to trigger a note. Now, of course, we're missing something to trigger a note with. So let's take a quick step back here and go and quickly create a synth. So we're going to make a global variable. Let's call it synth. And then in setup, we are going to say synth equals new tone.synth. We are going to give this synth for now a starting frequency. Let's make it 220 hertz, or we also know about note names, so let's make it a C4. And then we are going to connect this synth to its destination, which is the tone.master. And now that we have a synth object, we're going to be able to trigger a note here if this condition is met. So let's say synth.trigger attack release. And oh, actually the synth doesn't have a frequency, my bad. The synth takes some notes here. So we're going to put C4 as our note, and then we have the note duration. Let's make it an 1/8 of a note. Of course, this never triggers because we never update previous position. So after having done this, we're going to say make the previous position equal to the current position. That's a little important thing to do. Okay, so now we have a pendulum, right, moving back and forth according to a sine kind of oscillation. we're generating the oscillation using our LFO object, or low frequency oscillator. We're using a meter object to measure the amplitude of that frequency, and then we use that amplitude to set the position of our circle, thus allowing us to visualize the pendulum. And then whenever this virtual pendulum crosses the zero threshold here in the middle, right, we have him play a note. So in this case, it's just playing a C4 over and over. And this is the note duration. So now let's see what happens if we have a whole bunch of these pendulums and we get them to have, slightly increasing frequencies. And we're going to map each pendulum, to a different note as well. So in order to be able to replicate this pendulum, right, this is basically this logic code over here, and then the pendulum is an LFO, a meter, and a synth. We're going to have to create some kind of an object to store it. So we have some options here. We could try to define a pendulum object. We could go and create a function. Let's call it create pendulum. That would create a something like we've done before in the past, right? And then return the object being created. And then in here we might set the LFO would be equal to something and so forth. So this, we could do it that way, but just for the sake of bringing something new in this lesson, we're going to create our pendulum using a class. Now you may remember classes from processing or Java. We have classes as well in JavaScript, and classes in JavaScript are a little bit different from Java classes, but conceptually they're similar. They allow us to bundle some data inside an object alongside with some functions. So here's how we write a class in JavaScript. We're going to create a class called Pendulum. And then inside the class, we're going to have basically two different kinds of functions. We're going to have a constructor function. And this constructor here, we're going to put one parameter. That's going to be the frequency of the pendulum, and then another parameter that's going to be the note we want this pendulum to play when it hits the middle. So we're going to have a constructor, and then we can also put other functions inside our class. So for now, we're just going to put one function. We're going to call it run. Now notice inside in JavaScript, one big difference between Java and JavaScript classes is we don't even put the keyword function whenever we're defining things inside a class. We just go and put the function name right away. And then the constructor, unlike with Java, is just called constructor. Whereas in Java, we would have to use the name of the class as our constructor. So the constructor is the little bit of code that runs every time we make a new object, right? So every time we use the new keyword, the constructor for that class is going to run. So whenever we make a new pendulum, we're going to want to have a tone LFO and a synth. So let's bring these in to our constructor. Now in JavaScript, we have to use the keyword this whenever we work inside a class to refer to an object's own variables. So for example, if we're going to store, let's say, the frequency of our pendulum as a variable inside our object, we would write this.frequency equals the parameter frequency. Let's store the note as well. So in Java, the this keyword was kind of optional for classes, but in JavaScript, we have to use it. So same thing, we're going to say this.lfo. That's going to refer to that particular pendulum we're going to make its own object, right? So these objects are created inside the pendulum object. So the LFO, the meter, and here we're referring to meter, so we're going to say this.meter. And what we're doing is we're giving each pendulum its own LFO, its own meter, its own synth. And then we're going to take our drawing code that we developed over here. We're going to move it into the run function. Now, run here, this is a totally arbitrary name. Okay, I could create separate functions because we're doing a few things here where we're kind of running the pendulum by calculating the position and then triggering notes, but we're also doing some drawing, right, inside the function. Now, in my program, I always want those two things to happen together. So I'm just putting them all into a function called run. But we could have created here a function called draw inside our pendulum just for the drawing code, for example. But we're not going to bother with that for this this particular project. So here we don't have a previous position, so we're going to add this as a, actually just delete all of those. We're going to add previous position also as a parameter to our pendulum. And let's just make it equal to 0. And then here we're going to go and update our variables. So whenever we refer to meter, we have to refer to this .meter because we are writing this code inside a class. Whenever we refer to previous position, right, this is a parameter of our object, a variable of our object, so we're going to use this. The synth is a variable of our object, the previous position. And then we're going to change a little bit here how we're doing the drawing. So instead of going to half the height, we're going to go to 0. And here maybe we'll go to 50. And yeah, and this way we'll be able to spread our pendulums vertically. So I don't necessarily want to draw in the entire window here. And we're going to use just translate later to separate them. So we're not going to worry about this too much. So what we've done here by writing this class is we've created a template for making a pendulum object. When we're going to use the keyword new to create a pendulum, what's going to happen is the constructor is going to run. All of these attributes will be created inside our pendulum object. And then our pendulum is also going to get a function called run. So let's try it out. So we're going to make a pendulum. And in setup, now that I've made this class, I can write pendulum equals new pendulum. And I need to give it a frequency, right, and a note. These are the two parameters I've decided to put on my constructor. And then in draw, we're going to say pendulum dot run. Okay, so we have our functioning pendulum, and what we've done is taken, the code we started sketching with, and then we've packaged it as a class so that now it can be duplicated. Now I can see there's a little mistake here with my line, so let's figure out why that is. Oh yeah, of course. So we want this line to go from x0 like this. Okay, perfect. So now that we've made a pendulum, let's make a whole bunch of them now that we've made them into a class. So instead of a single variable, we're going to make this into an array, right? So this pendulum variable, we're going to call it pendulums, plural, and it's going to be an array. And then in setup here, we're going to create a for loop. So let's say we're going to create 7 of them to begin with. And then here we're going to say pendulums bracket I equals new pendulum. And then in draw, rather than just run a single pendulum, we're going to run all of them that we've created. So let's say for every, let's just call it P of pendulums. For every P of pendulum, we're going to say p.run. Okay. Must have been some funny thing that happened there when I was setting up the for loop that created some infinite loop. Okay. So now we've created 7 pendulums, and of course they're all drawn in the same place, so let's distribute them across the window. We're going to translate, and we're going to translate along y based on the height divided by, let's say, the number of pendulums we have. So there's a few things happening here. So even though I've set my pendulums, like they're all exactly to the same frequency, right? They have a little bit of a lag to them. That's because when I create my objects here and I hit start, right? The LFOs, they start whenever I call that function, as opposed to starting all at the same time. So what I'm going to do is I'm going to put a number here in start, and that number 1 here is, you know, the start schedule time. I'm going to say start this LFO, right, at 1 second on the transport. And by doing this, I know it's going to take way less than 1 second to create all of my pendulums. So that means that I'm delaying, right? I'm creating a delayed start time by 1. Okay, and that's going to ensure all my LFOs are going to start together. Okay? Because by the time we get to the 1 second, that 1 second mark, right, they're all being created. So now they're all in sync with each other. All right, now this is where things are going to start to get interesting. So I'm going to refresh here. We're going to add an offset to each of these pendulums, so they're not exactly at the same frequency. We're going to add a fraction, right? Let's say 1/60 to each of them. And then we're going to multiply this fraction by their index, so that they have successively increasing frequencies, right? So increasing frequencies. Oops, small mistake here in our class. We should have obviously used our frequency parameter, because if we don't do that, they're always going to be 85 or 0.85. Okay. So now just by offsetting the frequencies, right, we're creating this, so the pendulums are moving according to a sine oscillation, but then their overall relationship is also kind of sine-like, okay? Except over time they drift out of sync a little bit, and we get these very interesting kind of polyrhythms that emerge. Now this is a pretty annoying thing to listen to, because they're all playing the C4 note. Okay, so let's create a scale here. We're going to create a scale. And we'll say our scale will be, we're going to use tonal for that. And we'll say, get me the C4 major scale. And we're going to grab the notes. Okay? So now this is going to be an array of notes, 7. But just in case we add notes down the road, we're going to say scale.length here for our for loop. And then the note we're going to grab from the scale. And well, once again, slight oversight. In our class here, we don't want to always play the C4 note. Instead, we want to play the note variable that we saved. So this is going to get replaced by this dot note. So this is a little bit more interesting, because each pendulum has its own musical note. So let's add some more pendulums here to our program, just to make it a little bit more interesting. Right now we only get the 7 notes, right, starting from C4, and then we follow the major scale. In next week's lesson, we're going to talk a little bit more about MIDI note mappings, and we're going to have a slightly more clever way than this to expand our scale. But for now, let's do it that way. So what we're going to do is we're going to get tonal.js to generate the different octaves that we need. And instead of just having 7 notes, we're going to create 21 notes by taking the C3 major scale. And then to that, we are going to add the C4 major scale. And then we're going to add the C5 major scale. So we're going to span 3 octaves. And each time we're going to expand the original array that we started with. Okay. And the way we do this in JavaScript is we use the concat function from the array object. So what this does is it says, takes your scale array that you built over here, add this new array to it, right? So it's going to combine the 2 arrays into one. However, it doesn't modify this variable directly. It just outputs a new array. So that's why we have to capture it here and put it back into the scale array that we started with. And then we're going to do this again, except this is going to be C5. So now we should have 21 pendulums spanning 3 different octaves. So now we're starting to get into some more interesting patterns. Now this is going a little bit fast, so let's try to tweak this a little bit. We could tweak it here, right? So I could change this ratio, or another place we could change this is in here. We could just divide the frequency. Let's say we're going to divide by half. So at first, we're just running up and down the scales because the pendulums are pretty synchronized to each other. But then over time, they're going to start to drift. Right? And then we run through all these interesting complex sequences. Eventually they're going to catch up with each other, get back into sync again, and then drift apart. And it's just going to do this process forever. We're getting close to the beginning again. So actually it takes a little bit of a while to run through all the different possibilities. So let's make a few more tweaks just for fun to the sketch so far. Now, it would be nice to be able to try different flavors of scales, right? So let's make this a bit easier for ourselves. Let's make a variable and call it flavor. So let's say major. And then here, we're going to add this variable to our root, to our octave. We could also, make the root a variable if we wanted to. And now I can try different flavors. For example, instead of a straight up major scale that has 7 notes, we could use a major pentatonic scale that is a reduced version that only has 5 notes. And it's got a little bit more of a mysterious flavor to it. Or we could use a minor scale. And so forth. Another interesting thing we can do also is, now that we have generated this sequence, these three octaves of scale added together, we can also just shuffle our scale. So we're going to take this scale array and we're just going to mix it up. Now, it turns out that in the tonal.js library, there is a subsection, a module of the library called collection. It says there's some utilities to work with collections. These are useful. We're going to learn about these next week when we talk about doing inversions and chords and things like this. But for today, we're just going to do here, we're going to use the shuffle function from the collection package inside Tonal. So what that does is it says randomize the order of a collection, in other words, of an array, in place, right? So it's going to transform the array itself. So we can give it an array and it's going to shuffle the values. So let's try it. We're going to say scale equals tonal dot collection dot shuffle scale. And actually, we don't even need to do this equal because it says it shuffles it in place, meaning it will transform the array that we pass as a parameter. So now we have the same overall notes, right? Except they've been randomized. Let's go to a minor pentatonic. Let's slow this down a little bit. So now we can hear our randomized sequence, right? So this is just like to mess around with this and to make it a little bit more interesting. And then finally, the last thing we're going to do for this week's lesson, I'm going to show you how you would go about adding some effects to this using tone.js. So tone.js has a number of effects we can add to the sound, right? And the effects here, you know, there's like various distortions, some different flavors of reverb, some delays, some tremolos, and so forth. Some filters as well that can be applied to the sound. And the basic principle is the same for all of them. So tone.js is based on these blocks of sound getting connected to each other. So currently in our sketch, we have our tone.master block, which is the block that's at the end that's producing the sound. And then we've created a bunch of synth blocks. These synths are being connected in our Pendulum class, right? And they get connected to the destination, which is always internally tone.master. So if we wanted to create a reverb effect that we could apply to all of these synths that we're hearing, we cannot just apply the reverb to the master because the master is the end of the chain. We need kind of a middleman here that we're going to use basically as a mixer for all of our synths. And then we'll be able to apply the reverb to that mixer block in our chain. So let me see what I mean by, let me show you what I mean. So we're going to create a mixer object here. And the mixer is going to be we're going to define it before the pendulums. The mixer is going to be what's called a gain object in tone.js world. So a gain node in tone.js is basically a node that you can connect other sound nodes into. And then if you want, you can adjust their volume, but here we're not going to use it for that. We're just going to use it as a place where everything can connect into. Just a single point before we go to the master. Then we're going to connect this mixer to the destination, which is always tone.master. And then the big change we're going to make is in our class, we are going to connect our synths not to the destination, but we're going to connect them to the mixer object. And here I should have written new tone.gain. Okay, that's why it's not starting. So now we should hear the sound again, right? But then if we don't connect the mixer, for example, we're going to have no sound. So what we've done is we've connected all of our synth objects into this one mixer object. And the idea is now we have this mixer we can apply effects to. So for example, one of those effects might be a reverb. Actually, the other way around. We're going to connect the mixer to the reverb. And then we're going to connect the reverb to the destination. So we no longer need to connect the mixer directly to the output. Now we have the following sequence. We have a bunch of synths going into a mixer, then we have a mixer going into a reverb block, then we have the reverb block going to the output. Let's hear what that sounds like. So now we can hear the sound we had before, except it's going through this reverb effect. And just like with the synths and all the other objects in Tone.js, you can configure the parameters for the object directly into the constructor by passing an object, right, that has the parameters that you want to set. So the reverb I know has a wet parameter. So wet means by default it's set to 1, so it means all we're hearing is the reverb sound. We're not hearing any of the unaffected or dry signal. So if we wanted to get, let's say, a mix of both, we might say 0.5. So that's going to be half dry, half wet mix. So now we're going to hear the reverb. But we're also hearing our dry sound. Another parameter is the decay. That's in seconds. Let's put a really long decay. And now you can kind of hear in the background the reverb kind of going on for quite a long time. Let's put it even longer. And again, there's lots of other effects that you could explore. Take a look at the Tone.js documentation, but the general idea is the same. So we need to connect blocks, audio blocks into other audio blocks and create a chain of some kind. Because the master is the last element of our chain that's going straight into our speakers, if we want to affect the sounds before it, we need some kind of block to act as a middle block, right? And then in our case, that's the variable we call the mixer. And then we can connect that mixer into the reverb into the master. So we have a simple chain going, and then anything we connect to that mixer object will get the reverb applied to it. I'm going to let this unfold for a little bit, and that's going to be all for this week's lessons. I'll see you next week for more Tone.js in generative audio. Hello, me again. Just like in the previous video, right? I talked about how I made a few changes to the code to make sure that the audio was getting initialized at the right time. I've done the same to this final sketch here. So I've taken the code away from out of setup and moved it into its own function called initialize audio, which gets called on the mousePressed. And that's important when working with audio in the browser. You want to wait to initialize your audio objects until your user has actually interacted with the window. I've also added a bunch of comments for you to look at. If you want to explore different scales, here's some ideas of scale names. You can also look at tonal.scaletype.names if you want to see the whole range of scales you could play with. All right, see you next time.